Let's go JavaScripting! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today is the final video for 2021. Woohoo! So we're not going to be covering, things like what's the for loop do. We're not going to be covering getters or setters, or we're not going to explain the difference between 2 equal signs and 3 equal signs. Nope. Just like last year, today I'm going to give you a free game. Now, that's not much of a game. It's mostly trying to give you an idea of how you can design a JavaScript browser-based game. And it's a real simple game. So, like last year, for our holiday game 2020, I presented a game called Run Santa Run. And that basically, you had a Santa with some reindeer at the very bottom, and he had to move left and right while some things came down the screen. And the idea is to try to survive as long as possible. Well, this year, the game is called Krampus Night. That's Krampus is spelled K-R-A-M-P-U-S. And it's based upon the legend of where you had two people, Krampus and St. Nicholas. And St. Nicholas would deliver presents to all the nice kids, while Krampus delivered coal to all of the naughty kids. And Krampus Night was usually December the 5th, which is the day before St. Nicholas Day, which was on December the 6th. So the idea for this game here is that you'll control both Krampus and St. Nicholas, and you'll deliver presents to naughty kids or presents to nice kids, or coal to the naughty kids, depending upon the situation. But don't get it mixed up or you'll lose health. And then once you lose all your health, the game will be over. And I'll show you the game here in just a second. So that's my gift to you for the ending of 2021 for our final video. Let's take a look at Krampus Night. So before we take a look at the code of the game, let's take a look at the game itself. Now, this is basically the introductory screen to Krampus Night. I've got the high score, the score, and the health at the very top there. I got the start button at the very bottom. And it cycles through 3 screens initially. The beginning screen, Krampus Night, 5 seconds after it shows up on the screen, it will then give you the high scores, and these scores are stored in local memory, local storage, excuse me. And then finally it gives you the instructions. It kind of gives you the breakdown of what's going on here. And so the idea here is we're going to have Krampus, St. Nicholas, and a bunch of kids, and they'll be firing off presents and coal to try to get scores. So let me just hit the start button and kind of just talk you through what's going to happen here. So there's start button. Here's my St. Nicholas and my Krampus at the bottom of the screen. And I can use the arrow keys to move them. And as you can see, we already got kids going across the screen. They go from left to right and right to left at random points in time. So the idea here is that when I press the Z key, St. Nicholas will fire off a present. And that was a present that you saw right there. If I hit the C key, Krampus will fire off some coal. As you can see, that was some coal right there. So the idea here is that I want St. Nicholas to hit a nice kid, and I want Krampus to hit a naughty kid. And what's the difference? Well, the nice kids have a green shirt on, while the naughty kids have a yellow shirt on. Kind of hard to tell the difference between the two, but you can get there. If you hit the right kid, you get a point. Ta-da! If you hit the wrong kid, like give a present to a naughty kid or give coal to a nice kid, you lose 5 points on your health. And if your kid doesn't get either coal or a present, if they walk off the screen like they have been doing here, you'll lose 1 point of health. And that's why my health, which started at 100, is now at 67, and we'll just keep going down one at a time until I do something. So let's go ahead and play the game here, and let's just start. And I missed the first one. Oh, there's a nice kid. I get 2 nice kids at the same time. There's another nice kid. Yay! Oh, there's a bad kid. Oh, got him. Oh, got him too. You can hear the ding as it occurs when I hit the correct ones. So what happens if I hit the wrong one? That's a nice kid, so let's give him some coal. Oh, I accidentally hit 2 of them at the same time. That's a little bug in the game. Don't worry about that. Well, these are naughty kids. Let's see if I happens when I hit a nice one there. Oh, got that one correct. So that's what happened. Notice I lost 5 health each time I hit the wrong one. Yep, that one went wrong. Let's hit that one wrong again too. I'm gonna go ahead and hit wrong ones from here on out, just so we can finish up the game and show you what's what the next screen will look like. Because the next screen will look like here's the high score screen. Oop. Oh, that should finish it off. There we go. Game over. Well, that's it. So once the game is over, it will just either go to the main screen, or we can enter in our high score. And this will be which are my initials. And I click on save. and it just goes back to the normal screen. And notice that the high score came up to be now 16, and then when I get to the high score screen, it shows up, there's a 16. So that's basically all there really is to it. It's really not a whole lot there. So next thing I want to take a look at here is this. Let's take a quick look at the code. That's next. Okay, so let's very quickly go through the game. Now, I'm not going to go through a whole bunch of different things at one time and kind of go into details. I'm just going to kind of very quickly gloss over the game and take a look at some of the major points of it. First of all, here's my HTML file. Obviously, if I'm in a browser, I got to have HTML. So there's my CSS. Here's the high score stuff. Here's the pitch. The pitch is where absolutely everything occurs, and I'll cover that here in just a second here. Here's the start button. I also originally had a pause and a end button, but the fact of the matter is I just flat out ran out of time. I do, as a part of my hobby, I also do acting at some local theaters, and we're in the middle of a play right now, which is one of the reasons I'm a day late with this video here, and also this reason I've shaved off my beard. And I just flat out ran out of time to be able to get this out to you. But that'll be something we'll work on a little bit later on, probably next year. But the key here is, here's my Krampus Night module that I'm loading in. So let's take a look at that. And it does absolutely nothing. Literally, I mean, look, what, 4 lines of code there. The key here is that I have created a game class, and this game class is responsible for controlling everything. And in detail, is responsible for controlling all the different screens that are occurring on the system. And I'll show you those screens here in just a second. And then once the game starts playing, it will be responsible for playing the game. And then it will pass to control everything to the play class. I am passing it to a phaser game class, and this phaser game class is a class that is specifically created for the phaser graphics engine. Now, I'm using a phaser graphics engine instead of creating my own like I did on the Run Center Run game from the holiday game 2020. And this is because I wanted to allow it to be able to take care of all the animations, all of the running, all of the collision detection and everything. I didn't want to have to worry about that, so I used phaser game. If you like 3JS, or if you like Babylon.js, or you wanted to write your own, this is the point where you create your own engine game, phaser game class here, and then pass that as the engine over to the game. And then the game will take care of everything else itself. And then we just start. So let's take a look at the game. The game is very simple. Well, it's not simple. It just looks like a whole lot here, but it's real simple here. Here's all the different screens. So again, the game itself is responsible for cycling through all those different screens, and then when I hit the start button, for sending it off to play. So I load up all those different screens right here. Actually, here it is right down here. Here's all of my different screens. Now, with the screens, that's where the first place I use extended classes, where I inherit classes from a base class. What I've done here, let's go over to the screens, is I have created a base class called screen.js. And screen.js takes care of absolutely everything there is for displaying a screen onto the page. In this particular case here, the important parts is that I either display the screen as an HTML file, which is basically just straight HTML onto the pitch area of the browser. You remember I had, let's go back up here. I had the pitch ID here, so that section, the scene will either display it as HTML onto the pitch or as a playing field. And when I do the playing field here, I've got what's called a pitch class. And that pitch class is going to do all the graphics and everything. We'll discuss that here in just a second. So what this really means here is that the screen takes care of everything here. So all I have to do now is create classes for each individual screen. So for instance, here's the main JS, and all I'm doing here is just setting the HTML for displaying the HTML. That's it. I do absolutely nothing else. Same thing with instructions. Straight HTML. High score screen, just a little bit more. I've still got the HTML here, but I also got to figure out when to load up and when to list the high scores, which I got a class to do that too. And when there's a new high score, I've got that too. Now this is a lot more complicated because I've still got the HTML, but then I got all this different code here to be able to figure out how to do the inputs and to save the score and all that kind of fun stuff. And then finally, the game over screen and things like that. So the idea here is that if you notice that each one of these always extends scene. So this particular scene handles, the scene class handles absolutely everything for displaying that particular screen or that particular scene onto my playing field. And so all I have to do, if I want to do a new screen here, is just give it just this information. That's it. I don't have to do anything else if I just want to display HTML, and it will automatically display it as if it's a completely new screen. Now, I kind of did it that way, so in case you want to adapt this for React, Angular, or something like that, you kind of have a basis for creating components for all those different screens. So that's the screen there. That's the screen. So game obviously launches the game. Now, once I get to the pitch launches the engine. And remember, we defined the engine as the phaser engine. So let's go to Mr. Phaser engine. And that's located within this game engines here. So technically, you can create your own engines and plug them in. So this phaser engine here is something that's specific to the phaser engine, the phaser graphics engine that I use. Has great 2D graphics to it, and it basically contains contains all the code that will handle all of that. All I've got to do is be able to basically tell it what pieces to load up and what pieces to operate. And in this particular case, I've kind of split it into two sections. I split it into the player, which is the St. Nicholas and the Krampus at the bottom, and I split it into the targets, which is the kids and the kids at the very top. And then within the player, you also have the present and the cold, because obviously it originates from the player. So I've separated those two into player and into what I call the target engine. And everything reacts within one another from this particular point in time. All of it gets started when it creates, and then the game engine will run an update once every however quickly it needs to do it to be able to get 60 frames per second, in which case I run updates also on the player and the target engine, and the target engine will tell me whether the game is over or not. In this case, I'm finished at that point, in which case I destroy everything and then tell the main program through a custom event that, hey, the game is over, do whatever you need to do. In that case, it displays the game over screen and the game takes over at that point. And that's pretty much all there is to it. But the one thing I really wanted to show you, especially within the target engine and the player. Now, let's flip back over to the game, and let's just go ahead and start the game. I'll kill it once I'll do a refresh here once it does it. Once I'm finished explaining here. If you take a look at this thing here, what we got here is basically we got graphics for the kids going left to right. We got graphics for the kids going right to left. We got a graphic for the kid who is a naughty kid. We got a graphic for a kid who is a nice kid. We got a graphic for the coal being shot out from Krampus. We got a graphic for the present being shot out from St. Nicholas. We got St. Nicholas. We got Krampus, and we even got sounds. You know, let's see if I can get the other sound. Ah! I'm not very good at this. Here we go. Here we go. So we got the two different sounds. So all of that is actually, with the exception of sounds, all of that is actually handled through one class. And this is where I do a lot of extending for the classes, because if you think about it, the classes themselves, or each one of those images, really comes down to an image. That's it. And then once that image is created, then we have to do something with the image. So what I've done here is I've created a base image called avatar.js. And this avatar.js sole responsibility in life is to create a phaser image that the phaser engine understands. And that's what basically all this load section, for example, that's basically all it does there. How to add an image to the scene, things like that. How to add a sprite to the scene. How to add animation. You know, the kids sitting there running and everything. Moving the image, or moving it left, moving it right, setting the velocity of those kids as they run across there. So all this is handled by the avatar class. And you can say it's just a simple, not a simple class, but it's just an avatar class. But everything derives from that class. Everything inherits from this class. So for instance, let's take a look at Krampus and St. Nicholas. Here's the Krampus. There's actually nothing here, but notice it extends avatar. But by default, all I want this avatar to do is just to create an image, which all the Krampus is just a simple image. It doesn't do anything. And there it is. Same thing with St. Nicholas. It doesn't do anything, so all I do is just pass it what the PNG file happens to be. The kids are a different story. The kids are just a little bit more complicated. I've got a kid that extends the avatar, but each kid has certain attributes. For instance, I've got a kid who runs from right to left, who is nice, and a kid from right to left who's naughty. Same thing from left to right, nice and naughty. A kid will have a direction, what type it is, and all of this information, especially this create image here, its entire purpose in life is to be able to create that particular image and determine whether it's a nice kid or a naughty kid, or whether it's running from left to right or right to left. Now, that's all it particularly does. It doesn't really do anything past that. But now I've got to have something to handle the kid going from left to right and a kid going from right to left. So I've got left, right kid and right, left kid. So those two are fairly easy and straightforward. But the left, right kid also extends the kid. Remember, kid extends avatar, left, right kid extends the kid, and it does everything it needs to do to create either a naughty or a nice kid that runs from left to right. And the same thing with right to left kid here. It extends kid and does everything it needs to do to extend from right to left. So that takes care of all the kids. Well, I also have the ammunition. The ammo, as I call the ammo, also extends the avatar because again, it's just a simple graphic, and it does everything it needs to do to be able to fire ammunition. For example, there's the fire method that sets the ammunition to fire from the bottom up to the top. Here's the cease fire, which basically stops the ammunition and kills it, and checking for any kind of collision. Or actually checks for collision upon the ceiling there. That's all it really does to it. But we got two different ammunitions. We got coal and present. So there's the coal, and that's all there really is to it. And there's the present, and that's all there really is to it. Now, why did I do this? The reason is that maybe down the line I may have other ammunition that may have to do certain things, or maybe the present ammunition may not go as fast as the coal ammunition, or maybe the present ammunition, maybe later on you may have some sort of I don't know, little power-ups or something where you get 3 of them to go out, or does homing device or something like that. So the present ammo may be different from the coal, so by splitting them up like this, I can treat both of them differently. They all share the same code base, they all share the same attributes, but by having both of them as separate classes, I am now able to treat both of them differently. Same thing with the kids. I've done it that way so if I wanted to, I could treat the right-left kid or the left-right kid differently. I could treat the kid different. I can also just change both of them at the same time by changing kid, and I can change them all by just changing avatar. So that's the beauty of extending classes. I have a base class called avatar, which controls all of the graphics that you see on the screen there, and then I split each one out differently based upon their particular attributes, whether they're ammunition, the present or the coal, whether they're kids running across the screen, or whether they're just a player down at the bottom. So all I do, for the 2-bit classes, the player class, its entire purpose in life is to create the player. And it creates the player by, let me see if I can find it here. Where's that? There it is. It creates the player by loading up the Saint Nick, loading up the Krampus, loading up the ammos, and creating the keyboards for basically saying that, hey, give me some cursor keys and give me the fire keys of Z and C. And then there's movement. It tells you how it's moving. It tells you what happens when I press it to launch it, when I press the C or the C or Z. Here's the update area. This is what's called about once every, whatever the timing is to get 60 frames per second, where I find out whether I have pressed the Z key or pressed the C key or pressed the right arrow or pressed the left arrow. And then I check to make sure the ammunition has hit something or not. And that's all there is to the player one. That's all it does. And then you have, whoops, wrong one. Let's try that again. Target engine. And the target engine's responsibility, and this is probably the largest one of the group here, is to create all the different children. And then, here's where it loads it all up. And then every certain amount of time create a new target based upon whether I want a right to left kid or a left to right kid, a nice kid or a naughty kid, and how fast it's supposed to go. And it's also going to figure out how to do collisions, and that's going to occur during the updates. And if the health score gets down to less than or equal to 0, first thing I do is make sure the health score gets to 0, because 1 minus 5 is -4, and I don't have a -4 standing up there. And then I stop the whole shooting match. And when I stop, it sets the game over. And then within the update part of the game, the game says, "Oh, it's over, so let's just shut everything down at that particular point in time." And so that's basically it. There really is nothing else. If I go back to the game itself, the whole purpose of the game here is that, I'm sorry, not the game, phaser game, excuse me. The whole purpose of the phaser game is I am updating the player and updating the target engine. And that's it. And as long as the target engine said the game is not over, I'm going to continue on. Otherwise, I finish up. And that's it. There really is nothing else to it. And that's one of the keys that we wanted to do here, is that I wanted to be able to show you that you could just take a couple of base classes like I did with the avatar class, or I did with the scene class, and do functions that are the same for all of the different images or all of the different scenes, and then split each one of them out into the individual pieces so that they can perform different operations. And that allows me, if I found something wrong, let's say that affects all the avatars, I could just change the avatar code and all of the different images change. Or I could just change the scene code and all the different scenes change. Or if I found a problem just on the instruction scene, or just on, let's say, the coal ammunition, I could just change those classes and it won't affect anything else. And that's one of the beauties about doing extended classes. And one of the reasons you need a design like that is when you're thinking things through, is you need to figure out, okay, what are some base classes that are common to all the different pieces? And what are the, and then create those and then extend all your different pieces from that base class. It just makes your life a heck of a lot easier. Now, couple things I want to figure out. I want to show you here before we wrap up the thing is I've got the high score screens here. What are some of the things? What are some of the things that you might want to do with this program once you get it later on? Well, first of all, I almost, and again, like I said, I ran out of time. I almost got complete and total separation between the game and the graphics engines. The idea here is I would love to spend about 2 weeks completely refactoring this thing to where I have did a complete separation of the game mechanics and the graphics engines. And I kind of started doing that. That's what the game.js is for. Is the idea here was to be able to, let me bring up game.js. The idea here was to be, not game.js, I'm sorry, Krampus Night. The idea here was to be able to say, hey, I want to use an engine that's based upon the phaser JavaScript, or I want to use an engine based upon Babylon.js or 3JS or one of my own creation. I should be able to pass that engine into the game, and the game will figure it out from on its own. Unfortunately, it doesn't quite really work that way yet. They're still kind of connected a little bit more than they should really be. But that's one of the things that I would love to be able to do here, and it's something you might want to try to do if you get working on this game, is figure out a way that you can separate the logic of the game engines and the gameplay itself, and that will allow you to be able to create any kind of number of engines you want without ever having to touch the gameplay itself. And of course, there's a couple of bugs floating around here and there. One of the other things I would really love to see about this is to have some sort of configuration screen. I have got a config.js file which has a bunch of static data in it that, here's my starting health of 100. If you do a bad hit, like cold to a nice kid or a present to a naughty kid, you get 5 points subtracted from your health. If they go all the way off the boundary without getting anything, they get -1. If you do hit a kid correctly, you do get 1. You can change the speeds of all of that. So a lot of different things you can do with the config, but that'd be great if you could actually configure it within the screen itself. So that'd be another wonderful thing to do it. So that's basically it for the game itself on here. Like I said, boy, I tell you, like everything you do, you wish you always had a couple of extra times. But you can find a link to the repository in the comments down below, in the description down below. So make sure that you do click on that. It's completely free of charge to you. You can do anything you want to with it. You can grab it. You can call it your own. I don't really care. The idea here is just to pass along the information. So go grab it. Go play around with it. And if you want to, do a pull request. Put it in there. Let's let everybody share anything that you may have discovered. Like I said, this is our last video for the year 2021. We're going to take a well-deserved holiday break for Boring JavaScript, and we'll return either the second or third week in January. I haven't decided which one. Just keep an eye on this particular channel for updates a little bit later on, and it'll suddenly just appear. But one thing I do want to tell you about is that we're going to be introducing a new video series sometime next year in either February or March. I will be delivering some details of it probably right at the very beginning of the first of the year. So again, keep subscribing to this particular channel to find out a little bit more about that new video series. I guarantee you it's going to be a wonderful series. You're going to have a great deal of fun with it, and you will learn a lot about how to design browser-based applications with JavaScript. Mostly games, because I just enjoy doing simple games. But anyway, so again, thank you so much for sticking with us for 2021. Thanks for watching. We'll see you next year.